All right, here's a couple of good questions. After declining between 1940 and 80, the number of multi-generation has been increasing since 80, and that function can be used to estimate the number of Okay, um, after 1940. In what year were there 50 million multi-generational households? So f of x or h of x is how many multi-generational households. So the way I would do this is, here's my function. H of x is equal to 0.012x squared minus 0.583x plus 35.723. And so what I'm going to do is I'm going to plug in the 50 where the h of x is. So this would be 50 is equal to 0.012x squared minus 0.583x plus 35.723. Then since it's a quadratic, I'll subtract 50 on both sides to get a 0. 0 is equal to 0.12x squared minus 0.583x. This will be minus 14.277, I think. So now here I have a quadratic equation that I can solve. The picture is going to look something like this. And what they're going to be looking for are what the x-intercepts are. And there's probably only going to be one. Now the value of x that you'll come up with is the number of years. X is the years after 1940. So if you came out with a negative number, then I would discount that and only use the positive number. Now to solve that, there's no way I'm going to try and factor that. So what I would do is use the quadratic formula, minus b plus or minus, and away you go with that. And solve, and it'll come out to something where you're going to have a square root in it, but just plug that into your calculator so that you come up with a decimal answer. And I don't know, if it comes out to 50 point whatever. I don't know what the number is, but it'll come out to something like that. And they say to round it to the nearest whole number, so you would just round it to like 50. But the question says multi-generational households in what year? So if your x comes out to 50, you've got to remember you're starting at 1940, so you have to add 50 to that, so it would be 1990. Okay, another way you could do that is pop that into decimals. I would like on a test, I'd like to see this kind of work, but you can also, to check it, pop that into decimals, graph it, and look to see where it crosses the x-axis. And you could probably get fairly quick, or close. Here's another good question. Open box is made from a 10 by 40 centimeter. Okay. So 10 by 40 centimeter piece of tin. Cut in a square from each corner. Oh, square each corner. Oh, and then they fold all the sides up so that the box sort of looks like that. Got it. Area of the resulting base. So this area in here is 136 square centimeters. And they say, what are the length of the sides of the squares? So they're not telling us how much they're cutting. So I could say that they're cutting out x. And since they're cutting a square, both those sides would be x. And all the sides are going to be x of the ones that they're cutting out. But really what I want to know is the distance from here to there. So I know the whole distance from there all the way to the end is 40, but from here just to there, I'm not sure about. But I know it's 40, and since this distance and this distance are the same, I could really say that this part of the square from there to there, or the rectangle, is 40 minus those two x's. Same thing with the corner up here. That's going to be 10 minus the two x's. Because 10 is the whole way. If you subtract off the two x's, you get 10 minus 2x. So I know the area of any rectangle is length times width. Area, they say, is 136. The length is of the square, just the square, is 40 minus 2x. And the width is going to be 10 minus 2x. Okay, so now the idea is you'll FOIL this side, expand that out, get rid of the brackets, and then bring the 136 over to the other side to make it equal to 0, and then solve that quadratic. So I'll have 400 minus 80x minus 20x plus 4x squared. And then I'll minus the 136 to equal 0. So this would be 264, I think. Is that right? 0, 1, yeah, that's right. Minus 100x plus 4x squared. The x squared's positive on this right side, so let's just rewrite it so it's in the right order. Plus 264. Okay, I think all those numbers are divisible by 4. So let's go ahead and divide everything by 4. And you have to divide everything by 4. So x squared minus 25x plus, that'll be 66, I think. Okay, so now, I think I've done that right. 6, 2, 424, 66, yeah. Okay, so now you try and factor that. And I'm not sure what will factor. 6 times 11, that's not right. 33 and 2, I'm not sure what other numbers might go. So if you can't factor it, then you would try and use the quadratic formula. Let me just go back and see if I've done anything wrong. Usually it comes out a little nicer than that. So 40 minus 2x, yeah, and 10 minus 2x. 40 times 10 is 400. 40 times 2 is negative 80. Negative 2 times 10 is negative 20, yeah, and positive 4x squared. And 400 minus the 136 is 2, let me just check that. 136 and 264, is that 400? 10, that's 400, yeah. Yeah, I think it's all set up right. And 264 divided 4, 6. 66, I think that's right too. Anyway, so at this point then you try and factor it. If you can't factor it, away you go with the quadratic formula. All right, hopefully that helps you with those two.